In this chapter, we're mostly going to focus on earthquakes, but we're also going to talk about other ways that rocks can deform, where they can fold or they can fault, and we'll talk about the different ways and the different locations we can find each of these on our planet. When we're looking at earthquakes, an earthquake is just when we have a sudden, abrupt movement of one rock moving past and sliding against another rock. This generally happens along a fault. And a fault is where we had one large rock that has been fractured into two. And along this fault line is where we're going to have movement that is going to generate earthquakes. In earthquakes, once we have this slip or movement along the fault, are going to release seismic waves. And these seismic waves are just energy waves that radiate out from where the earthquake actually happened. And most earthquakes don't happen on the surface where we live, but instead happen inside of the earth. So the actual location of the earthquake is called the focus or the hypocenter, and this is underground. But since we live and work on the surface, we care about the location of the surface that's going to move or shake the most in an earthquake. So the area on the surface of the earth that is directly above where the earthquake actually happened is called the epicenter. Earthquakes can be caused by a lot of different things, but most of the earthquakes we have on our planet are very weak earthquakes. And these weak earthquakes are created by things like a volcano erupting, landslide, and a lot of movement in the area, as well as meteorite impacts. But even though our weak earthquakes are the most common, we care a lot about our really destructive earthquakes. These are less frequent, but they cause a lot of destruction for both humans and our property. But all of these really destructive earthquakes happen because of plate tectonics. When we have plates that are moving towards or away or sliding past each other, it's going to build up a lot of friction as these solid rocks try to slip past each other. So we're going to see that over time around our plate boundaries that pressure is going to build up. The book calls this stress, but I like just thinking about it as pressure, trying to squeeze things. So our plate tectonics is building up pressure. But because we're trying to move solid rocks past each other, it's not easily done. There's going to be a lot of friction holding those rocks in place. But eventually, if we put enough pressure on those rocks, a slip will initiate. And a slip just means that it suddenly slipped or moved forward in some way, so it's a sudden movement or rupture along this fault line. And it's not only going to release all of the built-up stress, it's going to cause an earthquake that releases that energy. But we'll see that once an earthquake happens in an area, something called elastic rebound will take effect. An elastic rebound is when the stress is relieved from a rock, it's going to cause it to move back to its previous position and its previous shape. I like to think about the elastic rebound like a hair tie. I can take a hair tie or just a normal rubber band and I can stretch it out. I can change the size and the shape of it. But once I remove all of that pressure, I stop stretching out the hairband and let it just sit on my desk, it's going to go back to its original size and shape. That is elastic rebound, and our rocks on our planet do it after an earthquake. When we look at our specific type of plate boundaries, we'll notice that convergent plate boundaries create the largest and the most powerful earthquakes on our planet. And this is because at our convergent plate boundaries, we either have mountain building, if we have two continental plates colliding, or we can have subduction occurring if we have at least one oceanic plate, where that subducted plate is going to create what's called a megathrust fault. These are going to create incredibly large slips. So the subducted plate isn't constantly moving. Pressure is going to build up over time and cause it to suddenly kind of launch forward deeper into the earth. And when this happens, it's called a megathrust. And this produces the most powerful earthquakes on our entire planet. And unfortunately, because we have subduction zones when there's at least one oceanic plate involved, this means that this massive earthquake at a megathrust fault also has the potential to create tsunamis, or these ginormous ocean waves that will move through and can completely destroy a coastal area. The convergent boundaries aren't the only type of boundary that can create these large and destructive earthquakes. We'll see that transform boundaries can do them as well. And that's because when we look at a transform boundary, it's not really just one fault or one broken area. We're going to see that that transform fault is broken up into lots of smaller segments that are all moving in relation to each other. So we'll see that some of these segments are moving very slowly over time. They're not very noticeable, and they produce very little shaking. So we call these fault creeps. The ground itself is very slowly creeping up on something. But we're going to see that more commonly, we're going to see lots of these smaller segments that are just producing a lot of really small earthquakes. It might be inconvenient, but it's not deadly. But we'll also see that other small segments of these larger transform faults will have been locked in location for hundreds of years, waiting for enough stress to build up for it to rupture. When we have this pressure build up for hundreds of years, this is what creates the most powerful and destructive earthquakes along our transform faults. So here we see that along our transform boundaries, these earthquakes occur in repetitive cycles. You might have heard about a 100-year flood, or a massive flood that happens on average every 100 years. But along our transform faults, we have periods that we would expect to see earthquakes. So for example, the last major earthquake in San Francisco was in 1906, and this happens on a 100-year scale. So we're over 110 years past due. 10 years past due our 100-year earthquake in San Francisco.